In the realm of multimodal learning, detecting harmful content in memes has emerged as a significant challenge. Unlike traditional text-based harmful content detection, memes require understanding and merging visual and textual aspects, making it even more complicated. To address this, a semi-supervised learning approach using multimodal data containing both images and text can ease the annotation process. Recent studies have focused on multimodal content, relying on visual linguistic pre-trained models such as Visual BERT and CLIP. Notably, CLIP, based on self-supervised learning, has been trained on a large-scale dataset and has learned popular concepts of visual and linguistic features, including memes. The hate clip per architecture, which utilizes clip encoders and feature interaction between modalities, has achieved the highest performance on the Hateful Memes Challenge dataset. Our proposed approach involves developing a multimodal semi-supervised learning model, consisting of two stages. The first stage involves unsupervised pre-training using the cross-modality auto-encoder, CROMAE, which is trained to predict one modality's clip feature from the other. The second stage involves supervised fine-tuning, where the pre-trained encoders of CROMAE are frozen to extract new representations from the original clip features. These new representations, along with the original clip features, are fused to predict the classification target, resulting in the raw and cooked features classification model, RAWNCOOK. The proposed SemiMemes method is designed to address the challenges of meme sentiment analysis, where the goal is to identify and censor harmful content. By leveraging in-labeled data and multimodal learning, SemiMemes offers a promising solution for social media platforms seeking to mitigate the dissemination of harmful memes. The approach is evaluated on two benchmark datasets, demonstrating its effectiveness in identifying hateful and misogynist content. The research highlights the importance of considering both image and text components in meme analysis, as well as the need for semi-supervised learning approaches to effectively utilize in-labeled data. The proposed SemiMemes method offers a novel solution for meme sentiment analysis, with potential applications in social media content moderation and online safety. The SemiMemes approach, comprising cross-modality auto-encoder, CROMAE, and raw and cooked features classification model, RAWNCOOK, is proposed for semi-supervised learning. In Stage 1, CROMAE captures the underlying distribution of each modality using two separate models, AE image and AE text, trained with mean square error loss to reconstruct one modality from the other. The models, consisting of linear greater than PRELU greater than linear layers, are trained on in-labeled data to learn the latent representations of images and text, driven by the distribution of the remaining modality. In Stage 2, the RAWNCOOK model combines the strengths of the learned latent representation from CROMAE and the original clip features for classification. The model incorporates the encoder part of two pre-trained CROMAE models, freezes them, and extracts latent features from clip features. These features are projected to 256 length vectors, concatenated, and passed through a final linear layer to learn the classification target. The use of PRELU instead of ReLU in the decoder allows the model to learn from negative values in the latent features. The authors evaluate their model on two multimodal classification datasets, MAMI and Hateful Memes, using a focal version of the distribution balanced loss to optimize the multilabel classification problem. The loss function, defined in equations 5, 9, adjusts the importance of positive and negative samples using the focal parameter gamma. The results demonstrate the effectiveness of the SemiMemes approach in leveraging pre-trained models and informative features for multimodal classification tasks. The architecture is illustrated in Figure 4, and the authors highlight the importance of using pre-trained CROMAE models to extract informative features from images and texts. The authors introduce SemiMemes, a novel multimodal semi-supervised learning method that addresses class imbalance issues in multimodal datasets. The method employs a rebalanced weight mechanism, defined as RK_I equals P plus P caret gamma 1 ZK_I plus nu I lambda B, where RK_I is the rebalanced weight, P plus and P are the positive and negative class probabilities, and ZK_I is the logit of the model. The authors evaluate semi-memes on the MAMI and hateful memes datasets, comparing it to state-of-the-art multimodal semi-supervised and supervised learning baselines. The experimental setting involves creating labeled and unlabeled sets for training, with varying proportions of labeled data. The ATOM optimizer is used with an initial learning rate of 1e4, and the learning rate is reduced after each epoch using a step LR scheduler. Semi-memes achieves higher weighted F1 scores on the MAMI dataset and higher AUROC scores on the hateful memes dataset compared to several baselines, including CMMLCLIP, TIBVA, and HateClipPer. The research highlights the importance of sentiment analysis for censoring harmful content, particularly in low-labeled data settings. Semi-memes leverages a combination of CROMAE and RAWNCOOK models to identify and classify misogynistic and hateful memes. The paper discusses the prevalence of Internet memes, the difficulties of the annotation process, and the effectiveness of semi-supervised learning in dealing with limited labeled data. The authors also provide an overview of deep semi-supervised learning, referencing various studies on multimodal learning, including Visual BERT. The paper discusses the Hateful Memes Challenge and the Hateful Memes dataset, as well as the findings of Memotion 2, a workshop on multimodal fact-checking and hate speech detection. The research emphasizes the importance of identifying and classifying hateful memes to ensure a safer online environment. The provided pages present a comprehensive literature review of recent works in multimodal learning, focusing on sentiment and emotion analysis of memes, visual models, and semi-supervised learning frameworks. A total of 26 research papers are cited, highlighting their contributions to the field. The first set of papers concentrate on meme analysis, including detecting harmful memes and their targets, dataset creation for sentiment and emotion analysis, and visuolingual metaphor analysis. These works demonstrate the importance of multimodal approaches in understanding memes, which are increasingly prevalent in online communication. Subsequent papers explore semi-supervised learning frameworks for punctuation prediction in conversational speech, multimodal semi-supervised learning, and comprehensive semi-supervised multimodal learning. These works showcase the effectiveness of semi-supervised learning in handling limited labeled data and improving model performance. Notable among these papers is the work by Radford et al., which introduces a method for learning transferable visual models from natural language supervision. This approach has significant implications for multimodal learning, enabling models to learn from diverse data sources. Another key contribution is the development of distribution balanced loss for multilabel classification in long-tailed datasets. This work addresses the challenge of imbalanced datasets, providing a novel solution for improving model performance in real-world scenarios. The author's thorough review of these papers underscores the significance of multimodal learning and semi-supervised approaches in tackling complex tasks, such as meme analysis and visual model learning. By synthesizing knowledge from these works, the authors provide a comprehensive foundation for future research in these areas.